Injection molding, a process which uses temperature and pressure to heat and form plastic material into a mold. Looking at a cross-section of the machine, you'll see first the hopper which holds the raw material, in our case it's polypropylene. That gravity feeds material down into the barrel. The barrel contains 5 heating zones and a reciprocating screw which uniformly mixes and pushes the material through the barrel to the nozzle. The nozzle directs the material into the mold through the runner. The mold shapes the molten plastic and rapidly hardens as the shot comes into contact with the cool mold surface, cooled by the water cooling channels in the mold cavity. Once the part cools, the ejector pins remove the part from the mold into a waiting container. Here's the machine in action. Programming the system is done by touchscreen. There are 11 icons around the word boy which all have to be opened up and programmed. Inside of them there's some subscreens. The first one that just opened up is the clamping unit close, where speed, clamping pressure, and distance all have to be programmed. Then there's the plasticizing screen where the pressure of the nozzle to the runner is programmed, along with a couple of other. Each screen has many subscreens, so there's, all in all, I think there's 33 different screens that had to be programmed with temperature settings, pressure settings, speed, cooling times, things like that. There's a lot to it. When we first got this machine, it took about 3 weeks of programming before we got the first part out of the machine. We were quite happy at the time. My hand's going wild here. Let's see, opening up the ejector pin screen. The speed of the ejector pins, the force of the pins, and how many times it activates is what's being recorded here. Here's a model of the mold with an ejector pin activating out through the pin port. Next comes the screen for where we set the temperature for the heating elements. There's upper limits and lower limits on each element. These temperatures are in degrees Fahrenheit. Next comes mold design. Mold design. It's important when you're designing a mold to make sure that you don't have any 90-degree angles. Everything must have a draft angle. You have to think about flow constantly. This is the cavity side of the mold. It makes these feet for the 358 project. It pops out through here. The other side of the mold looks like this. This is an ejector pin sticking through. There's 4 holes for ejector pins. I've just got one in here as a demonstration model. But this, at the end, removes the part from the mold. Flow has to be taken into consideration all the time. You can't have any solid square corners. You need to make sure that the material can flow smoothly through the mold. You can see these little lines right down here by my finger. These are draft holes to let air out. As the material enters the mold, you have to have the air escape out through these very small little channels. The part itself, this is called the sprue, and these little indentations here are the gate. So the material flows in through here, fills the mold, it hardens and cools, and then is ejected.